Welcome back. We are still on the topic graph of quadratic functions. In the previous video, we solved some questions on using the graph of a quadratic function to find the values of x for which the function y is positive or negative. In this video, we are going to learn how to use the graph of a quadratic function to find the values of x for which the function y increases or decreases as the values of x increases or decreases. Finding the range of values of x for which y decreases or increases as x increases or decreases. To help us understand this very clearly, let's consider this graph of a quadratic function. So we have the x-axis here and we have the y-axis here, and this is the graph of the quadratic function. To make things clearer, I'm going to write the coordinates of each point we have plotted on this graph sheet against it. The coordinate of this point is minus 3, 15. The coordinate here is minus 2, 8. The coordinate here is minus 1, 3. The coordinate here is 0, 0. The coordinate here is 1, minus 1. The coordinate here is 2, 0. The coordinate here is 3, 3. And the coordinate here is 4, 8. Now let's look at something here. From this point to this point, the x-coordinate here is minus 3 and the x-coordinate here is minus 2. So at this point, the x-coordinate is minus 3, but here the x-coordinate is minus 2. So there is an increase from minus 3 to minus 2. The x-coordinate here is minus 2 and the x-coordinate here is minus 1. So there is an increase from minus 2 to minus 1. From here to here, the x-coordinate increases from minus 1 to 0. From here to here, the x-coordinate increases from 0 to 1. The x-coordinate increases from 1 to 2, it increases from 2 to 3, and it increases from 3 to 4. So as we can see clearly from these points, as we move in this direction, that is, as we move from left to right on the graph sheet, the x-coordinates increases. So the x-coordinates increases from minus 3 to minus 2, from minus 2 to minus 1, from minus 1 to 0, from 0 to 1, from 1 to 2, from 2 to 3, and from 3 to 4. What about the y-coordinates? Let's look at that. The y-coordinate here is 15. The y-coordinate here is 8. So it decreases from 15 to 8. It then decreases from 8 to 3. It decreases from 3 to 0. It decreases from 0 to minus 1, which is at the turning point of the curve. But after the turning point of the curve, we can see that the y-coordinate increases from minus 1 to 0. It increases from 0 to 3. Then it increases from 3 to 8. So unlike the values of x that kept on increasing, the values of y decreases from this point to the turning point. Then from the turning point to this point, it increases. So it decreases at a point, then increases at another point. We can use this to divide the curve into two parts. The first part is what I've colored with red. From this point to the turning point, we can see that as the x-coordinates increases, the y-coordinates decreases. So for this part of the curve, the values of y decreases as x increases. And we can clearly see it here. X increases from minus 3 to minus 2, from minus 2 to minus 1, from minus 1 to 0, and from 0 to 1. But y decreases from 15 to 8, from 8 to 3, from 3 to 0, and from 0 to minus 1. So for this part of the curve, y decreases as x increases. We can find the range of values of x for this part of the curve. The range of values of x for this part of the curve is between minus 3, which is the starting point, and 1, which is the x-coordinate at the turning point. So for the x values for this part of the curve, They are between -3, which is the x-coordinate at the starting point, and 1, which is the x-coordinate at the turning point. The values of x between -3 and 1 will give you the values of x for which y decreases as x increases. We can write the values of x between -3 and 1 using a set builder notation. It is written as x is greater than or equal to -3 but less than 1. So on this graph sheet, the values of x that are greater than or equal to -3 but less than 1 will give us the values of x for which y decreases as x increases. Now you can see that here I've included -3 in the values of x. So x is greater than or equal to -3. That means that -3 is included in the values of x. This is because this point we have here is the starting point of the curve on this side. But in reality, the starting point of this curve is at infinity. Now this is what I mean. We can actually extend this side of the curve to include a whole range of x values. So as I've done here, we can extend this side of the curve to infinity. And when we do that, it will include a whole range of x values. And -3 is included in that range of x values. So we will have to include -3 in our answer. So on this graph sheet, for x values between -3 and 1, we can see that the values of y decreases as x increases. Let's look at the second part of the curve. The second part of the curve is what I've colored with blue. I'm going to take the ink off the page so that you can see it clearly. So this is the second part of the curve. We can see that it starts at the turning point and ends at this point. The x-coordinate at the turning point is 1. The x-coordinate here is 2, the x-coordinate here is 3, and the x-coordinate here is 4. So we can see that as we move from left to right, the x-coordinates increases. The y-coordinate also increases. It increases from -1 to 0, from 0 to 3, and from 3 to 8. So for this part of the curve, as the x-coordinates increases, the y-coordinates also increases. So y increases as x increases. For the first part, y decreases as x increases. But for the second part, y increases as x increases. We can also find the range of x values for the second part of the curve. As we have clearly seen, it starts from the turning point, and the x-coordinate at the turning point is 1. And it ends at this point. The x-coordinate here is 4. So for x values that will give you the second part of the curve, they are between the x-coordinate at the turning point, which is 1, and the x-coordinate at the last point, which is 4. So x values between 1 and 4 will give us the values of x for which y increases as x increases. We can write the values of x between 1 and 4 using a set builder notation. And it is written as x is greater than 1 but less than or equal to 4. You can see that here too, I have included 4 in our answer. This is because this point we have here, the point with the coordinate 4, 8, is the last point we plotted on this side of the graph. But in reality, we can extend this side of the curve to include a whole range of x values. Now this is what I mean. We can extend this side of the curve up to infinity. So it will continue as long as our graph sheet will allow us. And when we do that, we will include a whole range of x values, and 4 is included in that range. So for the values of x between 1 and 4, we will have to include 4 in our answer. So x is greater than 1 but less than or equal to 4. So on this graph sheet, for values of x for which y increases as x increases, we will have to choose values of x between 1 and 4. So on this graph sheet, for values of x for which y increases as x increases, we will have to choose values of x between 1 and 4. I hope it's understandable now. For values of x for which y decreases as x increases, we will have to choose values of x between -3 and 1. For values of x for which y increases as x increases, you have to choose values of x between 1 and 4. And it all makes sense because look at something here. I'm going to clean all the ink so that you see what I'm referring to very clearly. As we move from left to right on the graph sheet, the values of x increases, but the values of y, which is represented by the curve, decreases from this point to this point. So as we start here, we can see that the curve declines. It declines from this point up to the turning point. Then, from the turning point, the curve begins to rise again. It rises from this point to this point. So between -3 and 1, the values of y decreases. That is, the curve decreases. And between 1 and 4, the values of x increases. That is, the curve increases. I hope you understand that now. Now let's look at something here. We can see that for the first part, that is for the values of x for which y decreases as x increases, I included the x coordinate at the starting point, which is -3. So I included -3 in the values of x. For the second part, that is the values of x for which y increases as x increases, I included the x coordinate at the ending point, which is 4. So here I included 4 in the values of x. But in both cases, I did not include 1, which is the x coordinate at the turning point. This is because at the turning point, the curve is neither increasing nor decreasing. At the turning point, the curve is flat, so it is not increasing and it is not decreasing. So we can't include that in the values of x. Now we have considered the behavior of the curve as we move from left to right on the graph sheet. What about as we move from right to left? So this time we are moving in this direction from right to left. As we move from right to left, we can see that the x-coordinate here is 4. The x-coordinate here is 3. The x-coordinate here is 2. The x-coordinate here is 1. The x-coordinate here is 0. The x-coordinate here is -1. The x-coordinate here is -2. And the x-coordinate here is 3. So as we move from right to left, the x-coordinates decreases. As we move from left to right, the x-coordinate increases. But as we move from right to left, the x-coordinates decreases. But as the x-coordinate decreases, let's look at what happens to the y-coordinates. The y-coordinate here is 8. The y-coordinate here is 3. The y-coordinate here is 0. The y-coordinate here is -1. So for this part of the curve, which I've colored with blue, the y-coordinates decreases as the x-coordinates decreases. So for this part, as we move from right to left, the values of y decreases as x decreases. We already know the range of values of x for this part of the curve, and that is x values between 1 and 4. So as we move from right to left, the range of values of x for which y decreases as x decreases is x values between 1 and 4. Let's consider the other part of the curve. As we continue to move from right to left, the values of x still decreases, but the values of y increases. So it increases from -1 to 3, from 3 to 8, from 8 to 15. So for this part of the curve, which I've colored with red, as we move from right to left, the values of y increases as x decreases. The range of values of x for this part of the curve we already know is x values between -3 and 1. So as we move from right to left, The range of values of x for which y increases as x decreases is values of x between -3 and 1. So this is how to find the range of values of x for which y increases or decreases as x increases or decreases. We did this on a curve with a U-shape, but the principle is the same for a curve with an N-shape. As we move from left to right on a graph sheet, the values of x increases. As we move from right to left on a graph sheet, the values of x decreases. And for each one of them, you will see that the values of y increases at some portion of the curve and decreases at some portion of the curve. We can easily find the range of values of x for those y values by looking at the graph. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to apply what you have studied in this video to solve some questions. Bye bye.